Okay, so this is the 2024 Higher Level Maths Leaving Cert Deferred Paper 1, question 6a1. The function h of x is defined for x is real as h of x is equal to sine 2x. Write down h prime x, the derivative of h of x. Okay, so we have h of x is equal to sine 2x. We've just got to differentiate it. So h prime x then is going to be equal to, well, let's see, if you differentiate sine of x, you get cos of x. So in this case, it's going to be cos of 2x. Now, because we don't have sine of x, we have sine of a function of x, we've got to differentiate 2x. If you differentiate 2x, you get 2. So our answer is 2 cos 2x. Okay, let's have a look at part 2. So in part 2, we've got to use integration to find the average value of h of x from x equal to 0 to x is equal to pi over 6. So let's write that down. So we've got to do the average value formula. So it's going to be, let's see, 1 over pi over 6 minus 0 times the integral from 0 to pi over 6. And then we've got to integrate the function sine 2x. Okay, so let's do this then. Let's see, 1 over pi over 6 minus 0 is just going to be pi over 6. When you divide by this fraction here, we've got to just flip it upside down. So it's going to be 6 over pi. So now all we've got to do is integrate sine 2x. But if you integrate sine of x, you'll get minus cos of x. So it's going to be minus anyway. And then it's going to be cos 2x. However, if you differentiate, if you checked it by differentiating this, you'll end up with this extra 2. So you've got to get rid of that by multiplying by half. So it's minus a half cos 2x. Our limits then are 0 and pi over 6. We have 6 over pi anyway. So I'm just going to do this here by putting in these two limits. So first of all, I've got minus a half cos 2 times pi over 6 minus a half cos 2 times 0. So we have 6 over pi. Let's just simplify all of this in the brackets here. So we have minus a half cos, well, 2 times pi over 6 is just pi over 3. Then we have minus minus, which is plus half cos of 0. We have 6 over pi. So we have minus a half times, well, cos of pi over 3. Cos of pi over 3 is a half. And then we have plus a half. The cos of 0 is just 1. We have 6 over pi. So we have minus half times a half is a quarter plus a half. That gives us 6 over pi times quarter. That's 6 over 4 pi, or just 3 over 2 pi. So we were asked to use integration to find the average value of h of x from x equal to 0 to x equal to pi over 6. So our average value is 3 over 2 pi. Okay, so let's have a look at part B. So in part B, we have a function f of x, and it is defined from x between 0 and 5 inclusive. X is real. The diagram below shows the graph of the function. The graph is made up of 3 straight line segments, 2 of which are horizontal. Use the graph to answer B1 and B2. For what range of values of x, if any, is f prime x negative? Note that f prime x is the derivative of f of x between 0 and 5. So when you find a derivative of a function, really what you're doing is finding slope. And we want to know which part of this graph has negative slope. We can see that this part here, this line here, has a negative slope. This has a 0 slope, this has a 0 slope here. So this is the only part of the graph here that has negative slope. So let's just write that out. So here we're looking for x to be bigger than 1 and less than 2. Let's have a look at part 2 then. Part 2 says that a is a constant with a between 0 and 5. Write down the range of values of a, if any, for which this expression is positive. So we have the integral from 0 to some value, so from 0 to some value out along the x-axis of our function f of x. Okay, so let's just break down this graph a little bit. We have here this part of the graph, and if we take, let's say, out as far as 3 here, we can see that this area here is the same as this area here. The difference between the two is that this area here is above the x-axis, this area here is below the x-axis. So if you were to integrate this function f of x from, let's say, 0 to, this is going to be 1.5 here. It's 1.5, the x value there is 1.5. That's because you can probably see if you take this rectangle here, you've got a diagonal along here, and you have this value here, this y value is 2, this value down here is minus 2, so this value here must be 1.5, must be halfway along here. But anyway, this area here is the same as this area here. If you integrate from 0 to 1.5, you'll get a positive value. If you integrate from 1.5 out to 3, you'll get the same value, but it will be negative. So in other words, if you integrate from 0 out to 3, what will happen is the value you get when you integrate from here to here will just add to the value that you get when you integrate from here to here. So you can see you'll get 0. So for example, if you find that this is, when you integrate at 3, this will be minus 3. So 3 minus 3 will be 0. Now, if on the other hand you decide to go further than 3, let's say you go out here as far as 4, for example, so you're integrating this part here and you're integrating this part out here. Well, what will happen then is you'll end up with an extra negative value from here to here. So in other words, overall, you'll get a negative value. So the question asks us to write down a range of values of a, if any, for which this expression is positive. So for any value less than 3, this is 3 here. Any x value less than 3, we'll end up with this value here being bigger than this value here. So we will end up with a positive result. So in other words, we want x to be less than 3.